In 1992, a road crew widening a freeway in San Diego cut into something they didn't understand. Paleontologists arrived and found Mastodon bones, but the bones were wrong, snapped in fresh break patterns, laid beside heavy stones that looked like hammers and anvils. Years later, the lab result came back, 130,000 years old. That number has no place for humans in the Americas. None. If it's real, it doesn't move the timeline. It detonates it. Most scientists didn't argue. They buried it under one word: impossible. But this was not the first inconvenient date the field refused. To understand why they reacted like that, you have to understand what they were protecting. Because the bones in San Diego weren't the beginning of the problem. They were the extreme edge of a fight that had already been going on for decades, quietly, brutally, in conference halls and peer review letters and rejected grant applications. So let's start at that trench in San Diego. The site is called the Cerutti Mastodon site. When the bones came out of the ground, they didn't look like a kill. There was no skeleton laid flat. Instead, there were limb bones broken in a specific way, the spiral fracture pattern you get when bone is broken while it's still fresh, still full of collagen. Not the clean snap of old, dry, fossilized bone. And sitting right there among them were large stones, cobbles, in sediment that had no business holding rocks that size. The team read them as hammerstones and anvils, the kind of heavy tools you'd use to smash bone open for marrow. Then they dated the deposit. Uranium-thorium dating on the bone gave them roughly 130,000 years. Here's the part that tells you everything. Those bones didn't go straight to a headline. They went into museum storage, and they sat there for about 20 years, because the people who found them understood exactly what that number meant, and they understood what would happen to anyone who said it out loud too soon. When the paper finally landed in the journal Nature in 2017, the reaction was not curiosity. It was rejection. Fast, loud, and near total. And the critics had real points. There were no human bones at the site, no stone tools shaped by human hands, no hearth, no cut marks, nothing you could point to and say a person made this. Just broken bone and heavy rocks. The breakage could have come from the construction equipment that exposed the site, or from natural forces over 100,000 years of burial. So the date wasn't really the problem. The date was solid. What the date implied was the problem. Because to accept Cerutti, you would have to accept that some kind of human relative, not even modern humans necessarily, was in California more than 100,000 years before anyone thought the Americas held a single soul. And the field already had a wall built to keep that idea out. That wall had a name: Clovis. For most of the 20th century, the story of the first Americans was clean and confident. Around 13,000 years ago, a group of big game hunters walked across the land bridge from Siberia, came down through an ice-free corridor that opened between two great glaciers and spread across two empty continents. You could recognize them by their tools. Beautiful, fluted stone spear points, first identified near Clovis, New Mexico in the 1930s. Those points showed up all over North America. And for a long time, nothing older did. So the rule became simple. Clovis was first. Clovis was the founding population, and anything claiming to be older was by default a mistake. That belief didn't stay a hypothesis. It hardened. It became the thing textbooks taught, the thing museum displays showed, the thing grant committees expected. Careers were built on it. Reputations were tied to it. There was even a nickname, not entirely affectionate, for the senior researchers who policed early claims: the Clovis Police. If you came forward with a site older than 13,000 years, you weren't just going to be doubted. You were going to be interrogated, dismissed, and in some cases quietly written off as sloppy. And here's the uncomfortable truth. The model was reasonable. For its time, it fit the evidence people actually had. That's what made it dangerous. A wrong idea gets corrected. A reasonable idea that stops moving becomes a fortress. So when something older showed up, the field already had its answer loaded and ready. Contamination, disturbance, wishful thinking. The evidence must be wrong because the model could not be. Which brings us to the first man who broke the wall and paid for it. His name is Tom Dillehay, and the site was in southern Chile, Monte Verde. Starting in the 1970s, Dillehay and his team uncovered something that shouldn't have survived at all. A wet, boggy environment had sealed organic material that normally rots away to nothing. Preserved wood, the remains of hide-covered structures, hearths where fires had burned. Even, remarkably, what looked like a human footprint pressed into the ancient ground. And the dates came back around 14,500 years, more than 1,000 years before Clovis. And Monte Verde is at the bottom of South America, an entire hemisphere away from that Siberian land bridge. The reaction was exactly what you'd expect from a field defending a fortress. Dillehay wasn't just disagreed with, he was hammered. For years. Critics questioned his dates, his layers, his interpretations. The safer position, professionally, was that Monte Verde was wrong, and that position held for a long, exhausting time. Then, in 1997, something rare happened. A group of the most prominent skeptics agreed to actually visit the site, to walk the ground, to look at the evidence in person, and after they saw it, they conceded. Monte Verde was real. The wall had officially cracked. But notice how that acceptance arrived. Late, after a decade of a scientist defending his own credibility. There was no grand apology for the years of doubt, just a shift. And here's the thing everyone assumed at the time. Monte Verde was the exception. The one weird site that slipped through. It was not the exception. It was the first door. Because once you go looking, the pattern is everywhere. And the next case had been sitting in Pennsylvania the whole time, Meadowcroft Rock Shelter, excavated by archaeologist James Adavasio, starting in the 1970s. And what makes Meadowcroft so hard to wave away is the stratigraphy, the layering. This wasn't a jumbled mess. It was one of the cleanest, most carefully excavated sequences in North American archaeology. Layer after layer stacked in order, deep and undisturbed. And down in the lower layers were signs of human occupation. Tools, evidence of people, with radiocarbon dates that pushed back past 16,000 years, maybe further. Think about what clean layering actually means. The sediment above the artifacts was younger, the sediment below was older, the human traces were sealed in between. That's not something that just falls into place by accident, that's a sequence, a record. So the critics needed an escape hatch and they found one. Contamination. The argument went like this. The area has coal deposits. Groundwater moving through ancient carbon like coal or bitumen could have seeped into the samples and made the radiocarbon dates read older than they really were. It's a legitimate concern. On paper, it works. But here's where it gets stubborn. No one ever actually demonstrated that contaminant in the dated samples. It stayed a possibility, not a proof, and the layers just sat there, refusing to rearrange themselves into something the model could accept. That's the pattern you start to see. The easiest way to bury a date is to call it dirty and walk away. You don't have to disprove it. You just have to raise enough doubt that defending it becomes exhausting. And nobody knew that exhaustion better than the next man in this story. Jacques Cinq-Mars, a Canadian archaeologist who, in the 1970s and 80s, excavated a set of caves in the Yukon, in the far northwest, near the old land bridge, the Bluefish Caves. And down in those caves, he found animal bones that appeared to carry cut marks, the kind of marks left by stone tools slicing meat off bone, and the dates on some of that material reached back around 24,000 years. That was nearly twice as old as Clovis. In the one place where you might actually expect the earliest arrivals, right at the doorway from Asia. And the field's response? They didn't engage, they looked away. Cinq-Mars presented his findings, and instead of a serious fight, he got something quieter and more corrosive. Dismissal. His work was pushed to the margins, funding became difficult. The site that could have rewritten the entry point into the Americas was treated as an embarrassment, a curiosity, a claim from a man who'd gotten ahead of the evidence. He spent years watching his life's work sit in the shadow of a date the field wasn't ready to hear. And this is the cruel part. Not that people doubted him. Doubt is the job. Scientists are supposed to push on extraordinary claims. The cruel part was how fast caution turned into punishment. How quickly a serious researcher became a warning to everyone else. Don't be like him. Don't get out ahead of Clovis. Don't stake your name on a number the field can't absorb yet. For about 30 years, the safe answer was that Cinq-Mars was wrong. And then, in 2017, the safe answer fell apart. A researcher named Lauriane Bourgeon went back to the Bluefish Caves material, not to the field, to the bones themselves sitting in collections. And she examined them again, carefully, with fresh eyes and better methods, separating the marks that stone tools leave from the marks that animals and natural processes leave. The cut marks were real, human-made, and the dating held. People had been in those caves around 24,000 years ago, right through the coldest, harshest stretch of the last ice age. Cinq-Mars had been right, decades early, and the evidence had been sitting in storage the entire time, waiting for the field to be ready to look at it honestly. Notice when that vindication landed. 2017, the same year the Cerutti bombshell dropped. Suddenly the far edge and the defensible middle of this argument were surfacing at once. But there was no ceremony, no public reckoning for the 30 lost years. The citations just quietly shifted. Bluefish moved from the reject pile toward the evidence pile. The field adjusted. It did not apologize. And that's the moment the shape of this whole story comes into focus. One cave could be an accident. Two caves start to look like a pattern, and the pattern was pointing at something the field had spent generations refusing to see. Then the argument moved south to a cave in the mountains of Mexico, and it got even harder. Chiquihuite Cave, high up in Zacatecas. In 2020, in Nature, archaeologist Cyprian Ardelian published something staggering. Down in the cave's layers, his team had recovered nearly 2,000 stone objects. And the oldest layers dated back somewhere between 26,000 and possibly beyond 30,000 years. If those objects were tools, then people were in central Mexico during the absolute depth of the Ice Age, tens of thousands of years before Clovis. If, because here's the fight. Critics looked at those stones and asked a devastating question. Are those actually tools? Or are they geofacts, rocks that broke naturally through frost and rockfall and time into shapes that only look worked by human hands? And Chiquihuite had a weakness. No hearths in those deepest layers, no animal bones with cut marks, no ancient human DNA recovered from the sediment, just the stones. So the argument turned on the stones alone. And when your entire case rests on whether a rock was shaped by a person or by nature, you are in for a war. Watch the pattern repeat. A younger researcher. An extraordinary date. A serious, credible objection. And the same slow pressure that fell on Dillahay and Sink Mars, falling again on the next person to step out ahead of the map. The rocks were real. The meaning was the fight. And that fight is still going. But while archaeologists argued over sediment and stone, an entirely different kind of evidence was coming in from the labs. Evidence made of molecules, and it wasn't behaving either. Start with Paisley Caves in Oregon. Researchers there, led by Dennis Jenkins, found something most people would rather not think about. Coprolites, fossilized human waste. An ancient DNA extracted from that material came back human, with dates around 14,300 years. Older than Clovis, in a place far from the supposed entry point, with biological evidence of who was actually there. Then there's the genome of a child, Anzac 1, a Clovis-era burial from Montana. When that genome was sequenced, it tied Clovis people directly into the broader story of Native American ancestry, confirming deep roots on the continent. But it was another genetic signal that really refused to stay neat. In some populations deep in the Amazon, researchers detected a faint, strange ancestry signal, a trace that looked more closely related to indigenous groups in Australia and Melanesia than to anyone you'd expect in South America. Researchers gave it names, a ghost population, Population Y. Now, be careful here. This is a subtle, debated finding, and nobody is claiming Australians sailed to Brazil. But the mere existence of that signal does something important. It breaks the clean story. Because one simple wave of one people crossing one land bridge and spreading out uniformly should not leave a genetic echo like that buried in the Amazon. The bones were telling one story, the layers another, and now the genes were telling a third, all of them messier than the map. And then came the discovery that took this entire argument out of the laboratory and made it something anyone on Earth could look at and understand. Not a molecule, not a contested rock, a footprint. White Sands, New Mexico. In 2021, in the journal Science, a team led by researchers including Matthew Bennett published fossilized human footprints pressed into the ancient margins of a long-vanished lake. And these weren't ambiguous. They were tracks, a trail of people walking, adults, and children, small feet beside larger ones, moving across wet ground alongside the giants of the Ice Age, mammoths and giant ground sloths, and the dates, around 21,000 to 23,000 years ago. Deep into the last glacial maximum, the coldest, most locked-up stretch of the Ice Age, when the ice-free corridor everyone had built the migration story around wasn't even open yet. Sit with what that means. If people were walking in New Mexico 22,000 years ago, they did not come through a corridor that didn't exist. The founding story of the Americas had a geography problem, and you can't call a footprint a geofact. You can't say the rock broke naturally. This was a person, walking, a stride pressed into mud and frozen in time. The footprint outlasted the person who made it by 22,000 years. You can see where their foot came down. This wasn't a tool someone could dismiss as a rock. It was a walk. But the field had one more objection ready, and it was a good one. The original White Sands dates came from seeds of an aquatic plant called Ruppia. And aquatic plants have a known problem. They can absorb old carbon dissolved in the water they live in, which can make radiocarbon dates read too old. It's called the reservoir effect. It's real. It was a legitimate reason to hesitate. So the researchers went back. And this time, they didn't rely on the seeds. They dated pollen from land plants, which don't have the water problem. And they used a completely separate technique, optical dating, on quartz grains, which measures when the sediment was last exposed to sunlight. Different material, different method, independent of the seeds entirely. The dates came back the same, around 21,000 to 23,000 years. Same site, new methods, same answer. That was the problem, because the reservoir objection was reasonable. It really was. But look at what it also did. It bought the old model time. It let people set the footprints aside for a while longer, in the comfortable maybe. And that's the thing you start to notice across every one of these sites. The objections were often fair, and they also, again and again, happened to protect the old certainty exactly long enough. So now stack it all up. Monte Verde, accepted. Meadowcroft, stubborn. Bluefish, vindicated. Paisley, biological. White Sands, visual, and now double confirmed. Chiquihuite, still contested. No single one of these had to win the whole argument. Together, they made the clean, 13,000-year story impossible to keep teaching with a straight face. And now, with all of that behind us, go back to San Diego, back to the impossible number, 130,000 years. Here's where honesty matters more than drama. Most researchers do not accept the Cerutti interpretation, and they have real reasons. There are no human or human relative fossils at the site, no unambiguous stone tools. The bone breakage might have come from the heavy machinery that uncovered it. There's no known population of any human ancestor in the Americas at that time to have done it. Cerutti is not proven. It is, by any fair measure, an outlier that the field overwhelmingly rejects. So why does it belong in this story at all? Because of what it reveals about the edge. If Cerutti were ever supported, it wouldn't bend the timeline. It would snap it. And the reason the pushback was so instant and so total is that the field had spent decades learning to slam that door. But here's what changed. After Monte Verde, after Bluefish, after White Sands, the old confidence was already gone. Cerutti didn't land in a world that was sure. It landed in a world where the wall had already been breached in half a dozen places. Most archaeologists still say Cerutti is wrong. They're probably right. But the fact that the argument could even be made and taken seriously enough to publish in Nature tells you how far the ground had shifted. Even rejected, it exposed something. The field no longer had a comfortable edge to stand on. So if people really were here that much earlier, before any corridor opened, before the old map allowed it, then how did they get here? And why is the evidence so thin? The answer that's quietly taken over may be the most unsettling part of all. They may have come by sea, not sailing the open ocean, but moving down the Pacific coastline, hugging the shore, living off the astonishingly rich marine environment. Researchers like John Erlandson championed the idea. It even has a name, the Kelp Highway. Dense forests of kelp along the coast, full of fish and shellfish and seals, forming a continuous ribbon of food stretching from Asia all the way down the Americas. You wouldn't need an ice-free corridor, you just need boats and a coastline, and this is where it becomes almost cruel. Where were those people living? On the coast, on the beaches and river mouths of the Ice Age shoreline. And where is that shoreline now? Underwater. When the Ice Age ended, the glaciers melted and the seas rose by hundreds of feet. The entire coastal world those first people would have lived in, their camps, their tools, their hearths, their bones, is now drowned, sitting on the continental shelf under the Pacific. The ice-free corridor, the centerpiece of the old story, quietly lost its throne. And the best evidence for what really happened may be sitting in the dark, offshore, where inland archaeologists were never going to find it. Maybe the evidence wasn't missing, maybe it was underwater the whole time. So what actually happened to the old story? It's worth being precise, because this is where drama has to give way to truth. Pre-Clovis is now mainstream. That fight is essentially over, and the early arrivers won it. Monte Verde, Meadowcroft, Paisley, and the strengthening White Sands dates carried the day. Other things remain genuinely contested. The Chiquihuite tools, the exact routes and timing, the ghost signal in Amazonian DNA, and some things, like Cerutti, remain rejected by nearly everyone, sitting out at the far speculative edge. But here's what should stay with you. The old model did not collapse in one dramatic afternoon. There was no press conference where the field admitted it had held the wall too long, no apology to Sink Mars for the lost decades, no reckoning for how Dillehay was treated. Instead, the change came the way it always comes, quietly. A revised paragraph in a textbook, a softened line in a museum display. New papers that discussed pre-Clovis sites, as if the brutal fight to accept them had never happened. The map didn't burn, it just quietly changed shape, and everyone agreed to look forward. And the questions that are left are bigger than the ones we started with. How much older can it go? How many Cinquemars are still out there sitting on dates the field isn't ready to hear? How much of the real story is drowned off the coast, or misfiled in a museum drawer, or dismissed right now as contamination because accepting it would cost too much? The old story of the first Americans was not stupid. It was built honestly from the evidence people had, but it was too clean, it stayed clean too long, and the people who tried to complicate it too early were treated as the problem instead of the evidence. Go back to White Sands one last time, to that trail in the ancient mud, an adult, and beside them, a child. Small footprints, keeping pace with larger ones 22,000 years ago, in a place the old map swore was empty. They walked across that ground long before anyone said they could, and the footprint lasted longer than the person who made it, longer than the theory that said they couldn't be there waiting in the dirt for someone to finally admit what it plainly was. A person. Here. Too early. All along.